We are reminded of our smallness in the larger galactic perspective by the millions and thousands of structures in the heavens that sparkle at us on starry evenings. In the vast reaches of the cosmos, whose unexplored worlds might yet be asleep, which beings, and perhaps even living things, are awaiting our terrestrial gaze? Every new piece of information that scientists uncover about the universe adds to the overall picture of the cosmos. When scientists discover things that are concealed in the most remote regions of the cosmos, it becomes especially fascinating. Watch today's video to learn how scientists recently identified the world's most distant star and what other celestial discoveries made headlines. Excited about the universe's amazing wonders and groundbreaking discoveries? For frequent updates on these subjects, don't forget to click the bell and subscribe to Simply Space. By giving us a thumbs up, you're encouraging us and demonstrating that our post substance can keep you interested. Endel in the solar system, our central host star, the Sun, has enormous proportions that no other celestial body can match. It is somewhat less than 900,000 miles in diameter. Our blue home planet would fit more than 1.3 million times inside our bright parent star. To put this into perspective, but the lonely star that scientists were able to find recently with the aid of the Hubble Space Telescope is far more massive than our Sun. The celestial body is millions of times brighter than our central star because, according to researchers, its mass is 5,100 times that of the Sun. It is commonly known that it can take billions of years for light from far-off stars to reach Earth. The same is true of this fascinating new finding. The emitted light travels over the vast reaches of space for approximately 12.9 billion years before it reaches us. To put it another way, the star was there when the cosmos was only 7% as old as it is now. When the celestial body was discovered, it was named Endel. The meaning of this Old English phrase is similar to rising light or morning star. Given the above, it is evident why the discovery of Endel, which developed only 9.9 billion years after the Big Bang, is such a sensation. Normally, it is impossible to identify such old and far-off stars separately. Usually, they are far too faint. The so-called gravitational lensing phenomenon is responsible for our ability to include Endel in the star maps. This is the term used by astronomers to explain how massive bodies can deflect light. In essence, an object that seems to be in front of a distant source, like a star or galaxy, affects the light coming from that source. In this instance, the closer the light passes the cosmic lens, the more it is diverted toward the mass by such a gravitational lens. Several decades would elapse before the gravitational lens effect was discovered and formally verified, despite Albert Einstein's prediction dating back to the 1930s. Experts are currently using this phenomenon and some of its variants to detect a wide range of distant objects. The bodies behind very huge galaxy clusters can occasionally seem as numerous images when they function as galactic lenses. As a result, we receive 4 firmamental greetings from ASAR in the constellation Pegasus. Experts had previously been able to spot single separated stars with the use of the gravitational lensing phenomenon. However, there was a limit to the hunt for such far-off objects up until now. Anything more than 9 billion light-years from Earth could not be identified. As a result, Endel's 12.9 billion light-year distance we have a limited view of the star record. What we perceive in the vast stretches of the cosmos assisted the scientists during their finding. As a result, the starlight was magnified 1,000 times, enabling Hubble to photograph Endel. The first identification of the celestial body should set the stage for additional in-depth research. Experts aim to uncover some basic features of the far-off star through spectroscopic investigations of the James Webb Space Telescope. Among these is the debate of whether Endel was a double system or a single star. This fascinating study, like a cosmic voyage into the past. The asteroid has likely burst long ago due to its assumed high mass. A galactic first. The first 2 exoplanets were discovered in 1992 by a group headed by Polish astronomer Alexander Wolszczan. 30 years later, researchers in this fascinating discipline have achieved the next significant milestone. They were able to surpass the 5,000 milestone. Indeed, 65 hitherto undiscovered extrasolar planets have just been added to the star charts by experts. Recall that planets outside of the solar system that are gravitationally bonded to another host star are known as exoplanets. The initial finding in 1992, when scientists found two planets around a rapidly spinning pulsar rather than a Sun-like host star, demonstrated that our distant cosmic neighbors can occasionally be radically different. From that point on, the specialists understood that if planets could survive in the domains of such a neutron star, they could do so almost anywhere. The supposition turned out to be accurate, as is widely known. Scientists have discovered many more exoplanets in recent decades. Even while there are currently over 5,000 of these celestial bodies known to exist, billions more are thought to be out there just waiting to be found, and that's only in our own Milky Way. An Earth-like planet could use every second possible host star as a gravitational fixed point, which is equally fascinating. Put another way, the likelihood that we will find extraterrestrial life rises with each new exoplanet that is found. Mysterious solar waves. We must remember, though, that even the celestial bodies we are aware of still have some significant questions, especially in light of the innumerable planets and objects that will be found in the future. Astronomers have lately discovered a fascinating phenomenon on the Sun, which is one of them. This has to do with a novel type of high-frequency plasma wave that is currently incomprehensible. These processes include the formation of asymmetric vortices close to the solar equator, which subsequently orbit our parent star in opposing rotational directions. The fact that the plasma vortices travel 3 times faster than any known solar wave particularly shocked the experts. It is still entirely unclear what is causing this unexpected behavior. However, one thing is certain: wave-like instabilities in the plasma frequently occur on the Sun as a result of temperature variations in the Sun's interior, interactions between the plasma and the magnetic field, gravity, and self-rotation. However, the limitations of earlier explanations are being reached in the case of these unique observations. Upon examining data from a research conducted 24 years ago, scientists discovered that an unidentified kind of plasma wave essentially circles the Sun. By doing this, it creates a logical combination of clockwise and counterclockwise rotating vortices. The history of this occurrence is still entirely unknown to experts. The distinct ice volcanoes of Pluto. The existence of so-called cryovolcanism in our solar system has long been known. Indeed, on a number of cold moons of Jupiter, Saturn, and Neptune, cryovolcanoes have previously been found. As the name implies, cryovolcanoes emit readily melted materials like carbon dioxide, water, ammonia, or methane instead of boiling hot lava. The relevant substances exist in a frozen condition within the celestial body. The materials melt and rise to the surface due to the heat that exists there. After that, the expelled materials solidify once more and may accumulate to create deposits that are hundreds of feet high. An analysis of data from the spacecraft New Horizons over Pluto points to the presence of a hitherto undiscovered type of ice volcanism on the former member of our planetary system. But first, a basic question needed to be answered. Are there any ice volcanoes on Pluto? The specialists examined 2 intriguing candidates, massive mountains that end in enormous crater plains, in an effort to unravel this puzzle. It became evident after examining the data and a few pictures that Pluto's mountains are very different from traditional ice volcanoes. The top depressions are actually too big and too irregular to have collapsed later, with diameters as large as 33 miles. Moreover, no evidence of expelled debris was discovered by the scientists. Given that the topography exhibits almost no impact spots, it is even more odd since the entire surrounding area is covered in heights that are hundreds of feet high and up to 12 miles broad, a situation that seems highly unusual for typical ice volcanoes. The matching area needs to be quite young. The fact that the mountain under study is mostly composed of frozen water ice with a thin layer of organic deposits, frozen methane, and nitrogen ice supports this theory as well. The varying layer thicknesses demonstrate that the various regions of the region were produced at distinct times rather than concurrently. However, what is the Pluto Mountains' history? According to the researchers' explanations, the region is the product of a distinct cryovolcanism. Initially, massive heights were formed by the passage of viscous but mobile water ice to the surface. The distinct hills eventually combined to create the cohesive hilly terrain that Pluto shows us today. Confirmation of this intriguing theory would also indicate that the dwarf planet's innards is far warmer than previously thought by researchers. Actually, the fundamental requirement for water ice to become sufficiently mobile to gradually surface from below would be the internal heat. We'd like your feedback now. How do you feel about the fascinating new astronomical discoveries?